morning, this is Dr. Neil Thompson at the University of Maine at Fort Kent. This is a video demonstration of a method of calculating view sheds from many points along a line, such as along a highway. We will then count the number of times each location on the landscape can be seen from this highway, and following that, we will calculate the area that is visible from each point along the highway. We will prepare the data in ArcMap, perform the analysis in QGIS, and return to ArcMap for the final display. We have a digital elevation model, 10 meter pixel size. We have a road. These data are publicly available for New Canada in northern Maine. First, we need to check that the projections are the same between both of these data sets, or the whole thing will not work. UTM 19 north. UTM 19 north. Now, we need to use the tool generate points along lines. Our input feature is the road. Our output feature is going to Viewshed demo, calling this road points. Setting the distance to 10 meters. This will generate a point every 10 meters along this line. We're using a small data set, so this goes quickly. And yes, this is quick. The entire analysis at the landscape scale will take days. Good. We can now turn off our roads layer, zoom in, confirm to ourselves that we do have points every 10 meters. In some places where the road segments come together, you will have a distance of greater than 10 meters. If you were to check that box that said include points at the end of lines, you would have 2 points right here. That will work for now. So now we will go from ArcGIS to QGIS. And this is QGIS 2.18. There is a new version, 3.2. That version does not support the plugin that we need to use. If you're not familiar with QGIS, you access your data through the browser panel. If you do not see this browser panel, you go View, Panels, Browser. You can navigate to our data, Viewshed demo, and we need to bring in the elevation model and the points representing roads. Zoom in and see the data. And we need to have 2 panels open. One is the log messages panel, and the other is the processing toolbox. To bring those both into view, View, Panels, Log Messages Panel, Toolbox. To load the plugin, go to Plugins, Manage and Install Plugins. We need to first go to Settings and check the boxes that show experimental and deprecated plugins. We are going to be using what is considered to be a deprecated plugin associated with an older version of this program. That's again QGIS 2.18, which you can still download, where this plugin provides the number of times that each location on the landscape can be seen from the highway. With these selected, go back to All, Search. Plugin is called Senscape. Install plugin. Now, plugin will appear in the processing toolbox. Open up Visibility Analysis. This is a two-step process. First we need to create viewpoints, and then we need to go into the Viewshed Analysis itself. Double click. Now, our observer locations are our road points. The radius can be set to anything. 5,000 meters is default. Observer height defaults to 1.6 meters. We want to leave the observer IDs unchanged so that it records the feature ID for each point, which can then be associated with the point layer. The elevation model for the points is the DEM, and it will save to a temporary file that you can work with here. Run. Now, we have a new points layer that's exactly the same as our old one in terms of geometry, but this has associated with it the elevation data that's needed for the Viewshed analysis. The observer locations, this is the output viewshed points. Digital elevation model, the analysis type is binary viewshed, and rather than individual files, which would open up however many number of points that we have, we want the sum, and that's going to produce the count of the number of times each point on the landscape can be seen. We can again save to a temporary file, or we can set a file path. We want to keep that box checked. Run. Good. Welcome back. Now we have our output file. Display our roads above that. The lighter colors in this case are more visible. Now I'm going to export the output file, save as. Name that output. Saving as a TIFF file. 10 by 10 meter resolution. That's going to be important later. That's 100 square meters per pixel, or 1/100th of a hectare. Now, in the log messages panel, so you have all these data here. We need to copy all those, and that is the ID, the feature ID of each point, the total number of visible pixels, and the total area within the entire analysis that is potentially visible. So we'll copy that, bring that to Excel, turn those texts into columns, delimited by a comma. I'm going to make all of these text so that nothing turns into a date on me. So now we have FID, visible pixels, total pixels. So we can file, save as, we want to save this as a CSV file. Output areas. Yes. Close that. And don't save anymore. Now, back to our original here. We can add data. join that to our road points using the FID, validate the join, 623 out of 623. Perfect. If those numbers are different, something's gone wrong. Okay. Confirm this join has gone correctly. Save this. Data, export data to a new file. Now we can go into the attribute table, and remember now we have the number of visible pixels, but we want the area in hectares. Add field, hectares. Field calculator. Hectares equals visible pixels divided by 100, because each pixel is 100 square meters, or 1/100th of a hectare. Now we can see for this point here, 374.45 hectares are visible from that point. Now, let's symbolize that by the area visible. This will show which points along the road are of greatest importance in terms of visibility. Our value is hectares. I'd like to give 3 classes. Round numbers. What I'm doing here is editing the symbols so they don't have outlines. These points do come to overlap on the map, and if they have outlines, you can't interpret very clearly. So, quantities, value field hectares, 3 classes, some round numbers, pick whatever works for you. And now, you can see that this area tends to have a larger viewshed than this area over here. These areas over at the edge shouldn't be interpreted too much because their potential view is off the map. But you can see as you get down through this valley, this little gully here, you can't see as much, and that makes sense. So now we can add our output, and white as the color is not very effective. So let's change that from black to white to black. And now display the background value of 0 as blank. So if there's no visibility, it doesn't show up on the map. Now turn off our DEM. Now you can see the darker colors are visible more often on the landscape. Here's our elevation model. Let's change that. There. And now we can turn that off and on. And we can see this hill across this, I believe this is Soldier Pond here. No, it's not Soldier Pond. Anyway, as you're looking across that pond, the adjacent hillsides visible many times from the highway. Let's add a hillshade analysis. Windows image analysis. We will insert a multi-directional hillshade. Looks so that now Now this is currently displayed as a stretched value. We can classify that into a number of categories. Or say a place is seen less than 50 times. And if you have your points spaced out every 10 meters, that means for 500 meters of that road, the point on the landscape is visible. So now we can say if it is visible for less than 500 meters, it doesn't even matter. So little or no visual importance. Yellow, 50 to 100 times visible, and that would be 500 to 1,000 meters, so half a kilometer to a kilometer. Greater than that, red. So now we've classified our landscape into areas of little to moderate and high visual importance. If you had a proposed cut block here, you would consider that to be highly visible from this road. Of course, this analysis depends on a bare earth hillshade. You can do this if you have a canopy height model with canopy on to account for the blockage of the view by trees. I prefer to go with a bare earth digital elevation model because that shows the worst case scenario. If the landowner adjacent to the road should harvest the timber, if budworms should kill the trees here, if for whatever reason that view is no longer blocked by the trees adjacent to the road, this is the area that could be visible in that case. It's important to ground truth this if you have a particularly important spot. This analysis is demonstrated with the 10-meter national elevation model. That is contour-derived data that tends to be smoother than reality. Very soon we will have LiDAR publicly available for the entire northern part of the state of Maine. That should come in 2019. When you get to that point, running this at a 1-meter resolution is tempting, but will bog down the computer. Unless you have a very, very, very good computer, I suggest recalculating your elevation model to a 10-meter pixel size. I've tested this out and I've found no meaningful difference in the view sheds calculated, and a substantial decrease in computing time. If you have any questions regarding this analysis, my email is neil.thompson@maine.edu. I'd be happy to hear from you. Thank you for joining us, and best of luck.